All right, the room is filling up.
Sweet. I'll go ahead and get started. All right. Hello, and thank you for joining us. Today, Eric Jamois, Director of Business Development, will introduce the new ADMET Predictor 10.3 Flagship Machine Learning Platform for ADMET modeling with extended capabilities for data analysis, metabolism prediction, and AI-driven drug design release. A few housekeeping notes before we begin. We take your privacy rights seriously. By attending this event or participating in the Q&A session, you are allowing us to contact you for follow-up. You may ask questions via the questions panel on your dashboard at any time. If you need assistance, please use the hand raised icon. And before we get started, I have a quick poll. And the question is, are you currently using ADMET Predictor software? We'll give it a few more seconds. And it looks like most of you are, and there is some of you that are investigating options. All right, and I'll pass it off to Eric.
All right. Well, thank you, Jasmine. Good morning, good afternoon, and good evening to everyone. Thank you for joining us in this webinar featuring our most recent release of the ADMET Predictor platform. So today we're going to focus on the new 10.3 release, which will be marketed as APX.3. There are some general enhancements to this release, just to name a few. Access to MedChem Studio for all of our users. This was previously one of our optional modules, so it'll now be available to all of our users. There are some key enhancements to our AIDD module, which was released about a year ago, and David will also speak about the release of a new REST API. But I don't want to steal the thunder from David. So without any further ado, it's my pleasure to introduce Dr. David Miller, Vice President of ADMET Cheminformatics R&D at Simulations Plus. David, the floor is yours.
All right, thank you, Eric. And again, welcome everyone to today's release webinar for ADMET Predictor version 10.3. Okay. All right, so here is an outline of the webinar. For the benefit of those who may be new to the software, I'll first provide a brief overview of the ADMET Predictor platform as a whole. Then I'll outline the new features that we've added for this release. And then I'll take some time to briefly demonstrate some of those new features using the software. Okay, so the functionality of ADMET Predictor can roughly be divided into these four areas. The most well-known is property prediction. There are now more than 175 properties predicted from chemical structure in these areas. Physicochemical includes pKa, log P, log D, solubilities, permeabilities, and so on. Metabolism focuses primarily on cytochrome P450s and UGTs. There are enzyme-specific substrate and inhibitor classification models, kinetic models for the 5 major CYPs, and models of overall intrinsic clearance in liver microsomes and hepatocytes. We have substrate, inhibitor, and KM models for 10 important transporters. Toxicity includes Ames mutagenicity, hERG, and several other endpoints. And finally, there are customizable risk scores that predict overall ADMET liability as a single number. The predicted properties here are based on machine learning models that were built using training data from collaborations, commercial databases, or literature, and our user manual provides details on the data sources and the model performance. The high throughput pharmacokinetics module provides mechanistic simulations in virtual human or rat species. The simulations are similar to those from our company's GastroPlus software. You can estimate fraction absorbed and bioavailable and a number of important pharmacokinetic parameters. You can generate concentration time profiles and estimate the dose required to achieve a target user-specified plasma concentration at steady state. Our model building engine allows clients to build machine learning models using their own data. It's the same engine that we use for our commercial models. This module provides access to our proprietary set of over 340 molecular and atomic descriptors. Both regression and classification models are supported. And regression model predictions come with an uncertainty estimate and classification model predictions with a confidence estimate. And then finally, there are a number of useful cheminformatics features, like organizing compounds by common scaffold, R group analysis, and so on. Among the features for designing new compounds, we recently added one called Artificial Intelligence-Driven Drug Design, or AIDD, which discovers compounds simultaneously optimized across multiple target objectives that are chosen by the user. This release includes a nice improvement to that feature, as Eric mentioned, and I'll talk more about that later. There are several options for deploying ADMET Predictor. We have a command line version that runs on both Windows and Linux. This focuses primarily on the ADMET property prediction and the pharmacokinetic simulation features, but we are continuing to add new functionality to it. The ADMET Predictor prediction engine can be included as an optional module within our GastroPlus software. So it can provide estimates of properties for which you do not have experimental data. We offer both NIME and pipeline pilot components. And then, of course, there's the more interactive and graphical desktop version. This is currently Windows only. And then, as Eric said, for this release, we have added a new web API as another deployment option, so that property predictions and other ADMET Predictor functionality can be directly integrated into third-party software. I plan to provide more details about this in the subsequent slides, and especially during the demo portion. Okay, I have a few slides to briefly review the prediction methodology. So we start with our proprietary set of molecular and atomic descriptors, which include some particularly novel charged-based atomic descriptors that were developed over several years under an NIH grant. We use these descriptors to build a collection or ensemble of neural network models where final predictions are based on the average of the individual predictions within the ensemble. This shows the performance predicted versus observed of our PKA model, which has been ranked as the #1 QSAR-based PKA model in a number of recent challenges. Again, the user manual has these types of performance plots for all of our models. The pharmacokinetic predictions are different in that they are not based on QSAR models, but rather on mechanistic simulations. These utilize two components, the so-called ACAT model to describe transit through the GI tract, and a compartmental PK model to describe distribution and elimination. This overall model is an only slightly simplified version of what's used in GastroPlus when you select the option for compartmental simulations. The simulation setup requires input parameters like a compound's intrinsic clearance, log P or log D, solubility, permeability, and so on. These can be experimental values if you have them, or they can be predictions from ADMET Predictor or elsewhere. Running the simulation then involves integrating a system of time-dependent differential equations from which you can derive parameters like fraction absorbed and bioavailable, estimate concentration time profiles, and so on. And then quickly, I'll just briefly show some other useful companion features that I won't have time to talk more about today. For example, you can perform an in-depth analysis of a compound's ionization microstates, predict log D or solubility as a function of pH. You can create these kinds of graphics showing the atoms having the most influence on a particular prediction. This is the case of a hERG binding. And explore the BCS or DCS classification of compounds. There are many other features like that, but I hope that was a useful brief overview of ADMET Predictor as a whole. So now I'm going to switch gears and talk about the new features that we've added for this version 10.3. So the first release of the Web API is focusing on a core subset of the ADMET Predictor functionality. So ADMET property prediction, the pharmacokinetic simulations, and metabolite prediction. We do plan to expand the functionality over time based on user feedback. Just to clarify, the ADMET Predictor server will be running at the customer site, not at Simulations Plus. Clients communicate with that server using JSON formatted HTTP messages. Those messages can be encrypted as an option, and this uses the transport layer security 1.2 or 1.3. I'm going to talk a lot more about this during the demo portion. We did a lot of work to update our CYP metabolism models. So these include our substrate, non-substrate models, and the sites of metabolism models. For each of these groups, we have the 9 individual models for the different CYP isoforms. So we included data from more recent literature and FDA submissions and extensively recurated all of the data. This resulted in expanded chemical coverage. We had about a 20% increase in the sizes of the training sets, and we saw an overall improvement in the model performance. The charts here show the relative sizes of the training sets in the latest version versus the previous version, again, for the 9 different isoforms. This was a lot of work by the team. We've made an important enhancement to the AIDD feature, which is that external applications can now be used for computing the objectives. Those applications could be R or Python scripts, even docking programs, and so on. I'll just quickly go over how the AIDD feature works. So you begin with 1 or more seed compounds and a chosen set of objectives for optimization. Then the algorithm generates new compounds by transforming randomly selected compounds from the current population. This makes use of a database of compound transformations, and the user can modify that list of rules. Then for the current population, the objectives are evaluated. Those objectives can include our ADMET properties, fraction absorbed or bioavailable from the HTPK module, risks, or user activity models. Previously, these had to be built using our ADMET modeler software, but now with this extension, they can use external applications as well. Then the population is pruned to a smaller number of compounds by retaining only those that are Pareto optimal, and then that cycle is repeated. So for a user-specified number of generations, this whole process is repeated again. So ultimately, you end up with a set of virtual compounds that is simultaneously optimized against the user-specified objectives. So this is showing the user interface of AIDD with a new option specifying here that you want to use an external application. You provide essentially a parameter file here, and we provide a template for that. And then one of the options is to specify a script which will execute that application, and perhaps a program that is required to launch that script. So behind the scenes, the AIDD algorithm will be writing a temporary file that contains the chemical structures of the compounds in the current population. And then the script here is responsible for sending those compounds to the external app. And then that app, or the script, has the responsibility of writing the objective values to another temporary file, which AIDD will then read and use for the optimization step. So this happens over and over again. We've done a lot of testing of this internally using models built in R, using Autodoc, etc. And we look forward to working with clients to get their third-party tools working in their environments. We have expanded the command line functionality, specifically the script file workflows, which is where ADMET Predictor is invoked using a text file containing the parameters that control the run. So the first is a script file that can run AIDD, and that does include the new extension for third-party apps. We've added a new script file workflow to generate the same types of images that you see in ADMET Predictor's atomic properties window. And here's an example here showing the predicted sites of metabolism by CYP3A4. So that's a new workflow, and then we've extended the existing workflow for metabolite prediction and added the option to generate the kinds of images that you would see in the MedChem Designer software when you predict metabolites. So we call these the metabolite trees. So we had a couple of requests for this extension, so we've added it in this release. We've added a new method to standardize tautomers. So in this method, candidate tautomers are scored using an artificial neural network classification model that was trained on experimental data. This model was built with a special version of ADMET Modeler using a softmax activation function and cross entropy loss. We've provided some references here for those who are interested. You can see from the performance plot that the model performs well, both on the training set, which is shown in blue, and the test set in red. So here the true positives would be cases of the most dominant tautomer being correctly identified as such, and the true negatives, the non-dominant tautomers being correctly classified as such. The training set is a bit small for this release. It's about 1,100 tautomers for now, but we are in the process of expanding that. And this new model can be used without any additional paid license. It uses what we call the chemistry license, which is provided for free with any other paid license. And then on the topic of licensing, as Eric said, for this release, all customers will be provided licenses to the MedChem Studio module at no additional cost. This module provides a lot of useful cheminformatics functionality, things like scaffold-based clustering, R group decomposition, molecule transformations, match molecular pairs, similarity searching and diverse selection, ECFP and other types of keys, and access to our synthetic difficulty scores. I'm going to try to spend a little time during the demo just reviewing some of this functionality. Just a note that the compound design features that were previously included in the MedChem module are now part of the AIDD module. It made sense to group all of the features related to design into a common module. That was the reason for that change. Just a few other features I wanted to highlight. CP time profiles that are generated from the command line. So this uses the special CPT command line option. These can now be sampled to reduce the output file size, and the user has control over how much sampling to perform. PLS file format has been extended to allow the storing of intermediate results. Just as a reminder, PLS files, these provide a way for users to add new models to Predictor using equations based on existing models. So this extension greatly extends the types of equations that can be represented by these files. Our regression uncertainty estimates can now be displayed in MedChem Designer. And those same estimates are now represented using the lower bound, upper bound format. This is, again, the 1 sigma bounds. So it now has this format when exported from ADMET Predictor or written during command line runs. Previously, the uncertainty was reported as a single number, which is inconvenient because conversion to the bounds form is not straightforward for our models that use a nonlinear transform. So we had numerous requests to make this change, and so we're happy to report that we've done it now. Okay, there are many other features that we've added that you can read about in the manual and in the notes. But for now, I'm going to stop the slide presentation and get ready to do a short demo. But I think in the meantime, we have another short poll.
Yes. Thank you, David. So our second poll question is, what are primary interests in joining us today? And you can select more than one option here. I'll give everybody a few more seconds. And it looks like most of you came for just check out the enhancements to ADMET Predictor, which is really good. And I'll send things back to you, David.
Okay, thank you. Okay, so the first thing that I'll talk about is the new API. We've had a lot of requests for this. So hopefully this is going to work here. I have 2 machines now to be used. So I have a remote machine set up to act as the server, and I have remote desktop open here so that I can access it. So I'll enlarge that. So here on the server, I'm showing the Windows services pane, and hopefully it's a little small, I know, but hopefully you can see that there's a new ADMET Predictor service that is running. The executable for this service is provided as part of the ADMET Predictor installation. So you install this on a single machine chosen to be the ADMET Predictor server. There are no special requirements for this machine, but it does require a full ADMET Predictor installation and access to the Flexera license server. The service uses a configuration file shown here, where you specify the port number to use, whether or not to encrypt the communication, which ADMET Predictor licenses should be checked out, etc. I want to note that ADMET Predictor licenses are checked out when the service starts up, and they remain checked out while the service is running. This means that there won't be an issue with a prediction request being refused due to the lack of an available license. All of this is explained in a separate user manual for the API, and we also provide a lot of example JSON files to clearly illustrate the required syntax for the requests and the responses. Okay, so the service is running. I'm going to leave the server and go back to the local machine. So now I need to run client software to communicate with the service. So I have a mock graphical interface client that I'll show first. A lot of requests we've received for the API were from customers using software like Live Design or D360. So this mock client is meant to represent, that kind of software. So it'll give you an idea of what a fully integrated client application might look like. So I'll run this client to kind of demonstrate the API functionality. And along the way, I'll talk more about the required API syntax. Okay, so I'm gonna launch this kind of pretend client application. Just a note that we're not releasing this client application. Okay, so I'm showing some chemical structures. There's only about 50 structures here in the spreadsheet. The API is intended for relatively small numbers of compounds to keep the server available to all clients. But technically, there is no limit to the size of a prediction job. So first, I'm going to just show a kind of a settings page here, just indicating that we have the IP address of the server, the port number that was designated in the configuration file when the service was started up, the setting to use the encrypted communication is turned on. I've loaded the certificate file for the server. Okay, so that allows authentication and it has the public key in it and so on. I'll come back to a couple of these other options later on. So the first API that I want to show is related to retrieving the available properties for prediction. Okay, so there are a number of workflows as I was describing in the slides. So for example, for ADMET property prediction, if I click here, it sends a request to the server and I get a response back, and here it's a list of all the properties that you can predict. The list is going to depend on the licenses that you have, but you see it includes all of our models as well as the descriptors. So you have a description of each one, the type of data that it is, and so on. I'm gonna, for purposes of the demo, I'm just gonna select a smaller subset of these. Choose one classification model as well. Okay. For the PK simulations, there are two separate workflows. The first we call FA-FB. So that's the simpler one. You're just running one simulation at a fixed dose. So here you're getting back the fraction absorbed and bioavailable and the PK parameters. And then the more complex workflow is dose optimization, where you are running several simulations and you're mainly retrieving back the dose that would achieve a user-specified plasma concentration. There's a workflow to generate the same kinds of images that you see in ADMET Predictor's atomic properties window. I was just talking about that as a new command line feature that we added as well. I'm going to also uncheck most of these and just show a couple as an example. So like CYP3A4 sites of metabolism and intrinsic clearance by CYP3A4. And then for the metabolism, the metabolite prediction feature, again, there are sort of two workflows, one for cytochrome P450 and aldehyde oxidase, and then a separate one for UGTs. So I'm gonna demo this quickly, and I'm going to uncheck the minor CYPs here, the 2A6, 2B6, and 2E1. Okay, and then there's another set of APIs to retrieve the available parameters for each of those workflows. So for example, for the ADMET property prediction, it's things like pH. So that would affect our log D prediction and the pH dependent solubility prediction. Just like in the ADMET Predictor interface and in the command line, you don't have to specify actually any parameters. They're all set to defaults, and the API uses the same defaults that the GUI and the command line use. So these are optional parameters, but they're all explained here. There are equivalent ones for the other workflows, and I'll talk a little more about those later. Okay, so I'm gonna do the ADMET property prediction, and I'm just first gonna check on an option to archive the actual HTTP requests and responses, just to talk a little bit about that syntax. Okay, now I'm gonna launch the ADMET property prediction feature. I'm gonna check the option to create those atomic property image files on the server, just to illustrate that. So if I click calculate, it's going to send a request to the server. It needs to poll the server to check whether the job is completed. And when it is, the response back will contain all of the predicted properties, which can then be shown in a graphical user interface or whatever. You can see that the response contains information about predictions that are outside the applicability domain. And this client is choosing to represent that using the red color, just as ADMET Predictor does. There's also information about confidence, information about uncertainties, and so on. Now I'm going to show this file that was written here because of the option that I checked on. So this is going to show the actual the messages, both requests and responses. Okay, so this is the request that we sent for ADMET property prediction. You can see the body is in JSON format. Each compound must have an ID and some kind of representation. So the options here are to use smiles, which is the default, or to use an SD format. And I'm going to come back to that distinction in a few minutes. If I scroll past the compounds, there's a parameters section. Again, this is entirely optional. And then the list of requested properties. So it's pretty straightforward syntax. I get a response back initially, it says okay, and there's a unique job ID assigned to that request. The client then begins a polling loop using a different request, a different URI, this one called get status, and it provides the job ID that was sent in the initial response. So initially you may get a response like, this job has been added to the queue. It could be that the server is processing, hundreds of other requests from different clients. But eventually you should get a response back saying complete. You'll get the list of properties that was successfully processed, and then the results for each compound and each property. At minimum, you retrieve a value, and then perhaps optionally some uncertainty information, a case where a prediction was outside the applicability domain, confidence information, and so on. Pretty straightforward to parse this kind of response. We did request that atomic properties be generated as part of that calculation. Those are now residing on the server. So there's a separate API call to retrieve the images from the server. So I can select a single compound, issue that request. I'll choose predicted sites of 3A4 metabolism, and then that image is brought back to the local machine. One point to make here is that the orientation of the compound is totally different from what you see in the client application, and that's because we sent a smile string to the server, so it has no idea how that compound should be represented. So we had a request made to allow sending compounds using the SD representation, which has the 2D coordinates in it. So if you do that, then the images will look exactly as they appear in your client interface. I want to just briefly show one of the HTTPK workflows. It's a little bit more complex because here, there's the option to send data along with the compounds. So this mock-up interface here looks almost exactly like the one that's in ADMET Predictor itself. You can see that in the spreadsheet, we have an experimental HLM clearance value and an experimental solubility value. There are some missing values here, but in general, we'll assume that we want to use these, if possible, for predicting a fraction absorbed and bioavailable. So in this particular interface, there's a way to specify that. I'll choose the experimental clearance, and then here on a different dialog, choose the experimental solubility. And then I'm going to run it first, and then I'll show the HTTP syntax. So request made to the server, it comes back, it's very fast. And now I'll open up that HTTP file again. This is not normally written out, but I've added the option to add it out just for training purposes. Okay, so I need to find the request for FAFB. That's down here. So it's similar, but now in addition to the ID and the smiles, now we're sending experimental data with each compound. And these are using field names that are chosen by the user. Okay, and some of these values might be missing. So for this compound, there's no solubility. There's a compound here that has neither. So if I now go down to the parameters section, this looks complicated, but most of this is actually optional. But there's a special syntax that's used for kind of handling this case of experimental data, which might be missing for some compounds. And if you use the command line version of Predictor for HTTPK, you'll be familiar with this syntax. So here it's saying that if the experimental clearance is available, then it should be used. If it's missing, then the simulation falls back to ADMET Predictor's model of clearance. And then there's a similar thing for solubility here. If the experimental value is there, use it. Otherwise, fall back on the model from Predictor. The syntax here is taken directly from the parameter file that's used by ADMET Predictor. And if you use the command line version of Predictor, then you're accustomed to actually editing this file and inserting, the names of your experimental data fields right here into this file. So it uses the exact same mechanism for that. Again, most of this could be eliminated. These all, just revert to the same defaults as are used in the interface. I think with the exception of this one, I think you do need to specify a species, which is either human or rat. Other than that, the syntax here is exactly the same as it was for the ADMET property prediction. There is a workflow for generating concentration time profiles. It's a bit limited at this point. You have to send individual compounds in. In the future, we would like to extend that so that these profiles are automatically generated each time you do an HTTPK run. So hopefully for the next version, we'll have that. But for now, you would select a single compound. There's a separate API for CP time curves. It takes the exact same parameters as for the fraction absorbed and bioavailable. So here I'm still using the experimental clearance and solubility. So I run that. And here, it's not an image file that's being returned, but it's the actual data. So it's the concentration and time points that are being returned over the HTTP. So you can render that or you can save it to file. Let's see, and then finally, for metabolite prediction, you can do that using a single compound or multiple compounds. Oops, I'm going to choose just one. Like the interface, we have the options for the SIP-AOX workflow or the UGT. I'll just for simplicity do the SIP. I'll do it on just one compound. Options are similar to the interface. Here, I'm going to select this option to generate the images for the metabolite trees. So if I click calculate, that'll run quickly. And then now there are separate APIs to retrieve the chemical structures that'll pull an SDF file from the server or the image that we requested. So if I show that, you'll see this is the exact same image that you would see in MedChem Designer if you were to predict the metabolites for this structure. Okay, I think that's all I wanted to say about this sort of complicated client. But I wanted to just briefly show a much simpler client just to make a point here. So this is just a shell script here. This one is used to submit a log P prediction request taking a single smile string. So it's very simple. It takes a single argument, which is the smiles, constructs the body of the HTTP. It uses a widely available piece of software called curl for network communication, and then uses HTTPS to our server address at the port, and then using this unique URI indicating that we want an ADMET property prediction. So here in the body, we see that we specifically mention S plus log P. So very simple. I can just run that from the command line here, and I'll give it benzene. So there's a lot of information here about encrypting and decrypting the data since we're using SSL, but ultimately you get the OK response with the unique job ID. And then I have an equivalent simple script here to retrieve the result. So we can't assume that we're just going to get the result immediately, since the server may be processing hundreds of other clients. But again, here we are providing a job ID as a parameter and then making a very similar request to the service, but with the get status URI in this case. Type that in, job ID 5. So now you get S plus log P, the value, and the uncertainties. So I just wanted to show this to illustrate that client development, can be quite simple, and we envision people using, Python or Perl or what have you for being able to interact with the ADMET Predictor server. We are, committed to helping customers with their client development. Okay, I think that's all I had planned to say. Just looking at the clock, I have a little time left. Just going to launch the newly released, I believe this is now up on ShareFile. So this is the newly released X3 graphical interface version. I just want to talk for a few minutes about some of the functionality that's in the MedChem Studio module, which again is now going to be given for free to all users. When you have that license, there are a few changes in the user interface. You see some new tabs here at the bottom, like the classes tab, R tables, pairs, and keys. Let me open up a kind of an illustrative data set here. Make sure I have the right folder. So this is a set of virtual compounds, some of them a bit ugly. Let's see, there's 1,200 compounds total. So I'm just going to walk through a few of the MedChem features. The chemistry menu, when you have the MedChem license, has a number of additional options that wouldn't be visible otherwise. The first one of these is called Generalized Transforms. So this allows you to make kind of arbitrary modifications to the compounds in the spreadsheet. There's a lot of different options here. For example, we provide a file with the ADMET Predictor installation called Standardize that has keywords in it like remove common fragments, neutralize, standardize functional groups, standardize tautomers, and so on. You can also draw a transform. This is kind of related to Tautomer standardization. This one was drawn using our MedChem Designer software package. This does have the facility to draw reactions, but you can also, paste from ChemDraw or whatever other sketch tool that you're using. So you can run this and it very quickly makes changes to the compounds, and you see the new compound here and the previous one here. You can of course undo that if you've made a mistake. Another useful feature offered by the MedChem module is organizing compounds into chemical families. Ordinarily for that, you would activate this separate classes tab. Here it looks very similar. You see the same compounds, but here you have the flexibility to organize compounds in lots of different ways. You can do it manually using substructure searching, or you can use one of the automated methods. The default method is called frameworks. It's based on the famous paper by Bemis and Mirko, essentially ring system scaffolds. It's very fast, even on hundreds of thousands of compounds. On this data set, it reduces those 1,200 compounds to just 10 chemical families. You can see that the common scaffold is shown highlighted in blue. You have the number of compounds in each class. You can add any number of these sort of histograms for various properties and so on. Another useful feature is alignment. So if I take just this class, I'm going to show the individual compounds within this class. I'm going to do it using the this 2D scatter plot. But you see that the scaffold ring system has a different orientation in all the compounds. But once you have the scaffold defined, you can quickly align all the compounds in the class according to the single orientation that's shown here. If I wanted to modify this single one, I could do it first. But if I just leave this one here, there's one command to just quickly align those compounds, and then now they all have a standard orientation. Once you have the scaffolds and all the compounds are aligned the way you like, it's very easy to generate R tables for all the classes like this. So you see the R table scaffold shown here. We have functionality to look for subclasses within a class. So in a case like this, you may be interested in subsets of the compounds that have common R substituents. So there's a feature for that. It's a little bit complex, but I'll just run it, and I think it's fairly intuitive when you look at the results. So it found two subsets. In the first one, R groups 2 and 3 are just hydrogen. In the second one, it's R groups 1 and 4 that are just hydrogen. So that's a useful feature for breaking kind of a large, complicated class into simpler subclasses. To look at the R table, there's a separate tab where you can see kind of the traditional MedChem view with the substituents in separate columns. And then there's also kind of an interesting matrix view where you can look at all the R1 substituents against all the R2 substituents here. You can choose one or more properties, like this is a PIC50. So you see the coloring, you can sort to get all the actives in one spot and the inactives in another, and kind of look for the sort of correlations between the R group substructures and the activity values, for example. Okay, so that's a useful feature. And then I'll just show one feature related to similarity searching. You can, of course, do similarity searches within the spreadsheet, but there's another useful feature to perform a search against an external library. So once you have the MedChem license, there's a new menu item here called library. So to use it, you would first take an SD or Smiles file and construct a library using this menu option. So this essentially formats those structures so that they can subsequently be searched very quickly. And I've done this ahead of time for the Chembl database, which has about 1.5 million structures. So if I take this first compound and do a similarity search, I can choose that Chembl database. There are some similarity criteria here. If I launch the search, it's extremely fast against that size of a data set. It opens up a new instance of Predictor. And first it shows the query structure that we used, and then these are the hits from the library. Here in this view, they're not that well oriented, but if you activate this pairs tab, which again is part of the MedChem module, this is usually used for match molecular pairs, but you can also use it for looking at the results of a similarity screen. In this view, the query compound is always shown on the left. Hits from the library are shown on the right. The compounds are always aligned to one another. The structural differences are shown highlighted, and the whole spreadsheet is sorted so that the most similar hits are at the top, and then it gets less similar as you go down. So this is a useful feature. You can create these libraries for your corporate collection, or some literature collection, or patent collection, and so on. Okay, I think I'm looking at about maybe 8 minutes to go. The only other thing, just quickly to point out, I won't run these, but if you look at the design menu here, this is now going to be active only if you have an AIDD license. And you'll see that now, in addition to the AIDD feature, there are the other features that were previously part of MedChem. And there's a lot of useful functionality here for creating virtual libraries. I don't think we have time to really go over them. So at this point, I think it's a good stopping point. So I'll turn it back over to Eric and Jasmine for the Q&A session.
Sure. Well, thank you, David. That's a lot of really interesting new information here, I'm sure, for a lot of our users. So yeah, thank you. So Jasmine, I think we had a couple questions in the queue, and I can see one here. It goes, will I have to get a new license for this new version if I already have ADMET Predictor? Well, that's a good question. The answer is the configuration that you have right now will run on your existing licenses. So APX.3 will run on your existing set of licenses, but you do need to reach out to our licensing group, and that is licensing@simulations-plus.com, to request this new license feature for the MedChem Studio module that David just presented. So, so it's both, again, the existing set of functionality that you have that you've purchased will work, but if you want this new free functionality that came from the MedChem Studio module, then you will need to come to us and request a license for that. Now, here are some more that came in. We have a question concerning property predictions. Are these all based on 2D structures, or are there some based on 3D? So I know that some of the models are, there's actually multiple versions of some of the models, like volume of distribution has both 2D and 3D for both human and rat. But David, maybe you want to add some details to that.
Yeah, I don't think I have the full list in my head, but as you mentioned, there's a subset of our predictive models that have both 2D and 3D versions. We use a slightly different set of descriptors when we are building the 3D models. And of course, if you're going to use those models, you need to generate 3D structures first. That's a capability that we don't currently have. But so, we kind of suggest that users experiment with both. So one, you need to have the capability as of now to generate 3D structures on your own. And then it would be useful to make a comparison between the predictions you get from the 2D and the 3D. Broadly speaking, they're similar.
Yeah, I think there's an added complexity certainly from using the 3D model and some conformational dependencies, which may or may not be worth it to get into that complexity for the difference in the in the prediction. I mean, it's an interesting topic, but
yeah, it's one that we are certainly interested in.
Mhm.
We don't have anything, new to announce on that now, but it's an area that certainly is of interest to us.
Okay. All right, thank you, David. And then we have another question here regarding one of the first slides that you had up concerning the modes of access to the software, and in particular relating to cloud access. Is it possible to use KNIME in combination with cloud access? So pipelining tools or workflow tools, as they're called.
I mean, we certainly run ADMET Predictor in the cloud. I'm trying to kind of think through that question. I want to answer, yes, we have so many different configurations that are being used. With ADMET Predictor running in the cloud, the license server running in a different cloud, the pipeline pilot server running in yet a different one. I would suggest maybe this user send a specific question to us, the details their configuration, and we can get back to them. But we offer just a wide variety of different configurations. So, there's no problem with running in the cloud.
Okay. Well, thank you. A couple more is, so, and I think that one goes a little deeper to about, what the software looked like about a year ago from the way that it looks now. And the question goes, is ADMET Predictor 10 pretty much the same as APX 10.3? What are the major differences? And I mean, you went through some of the differences between 10.2 and 10.3, but there were some very significant enhancements that we brought from version 10 to 10.2, in particular relating to the HTPK development. So maybe you want to say a few words about that, because there was a lot of mileage that was covered between 10 and 10.2.
Yep. Again, I'm going to have to, maybe check back on some notes. I think the best thing would be to consult the webinars available on our website to see the full list of changes from those versions. But I agree. I mean, what comes to mind, from the last release, I think were all the HTPK enhancements that were made, kind of nicely summarized in that separate webinar that we had from Roche. But there were just a large number of other changes as well. I can't quite envision the entire list at this particular moment.
Yeah, it was very extensive. I mean, I forgot exactly at what stage the IV bolus came in, but there was certainly that. And then also the definition of C average and the fact that we can optimize based on C average, C mean, and C max. I mean, there were a lot of enhancements to the HTPK technology that were brought along from version 10 to 10.2. So, I mean, here we focused on 10.2 to 10.3, but for those clients who have remained on version 10, we would certainly encourage you to, if you haven't made the move to 10.2, definitely, take on 10.3. And especially if you're a user of the HTPK technology, it's pretty much a must-have at this point.
I think that the README file notes from prior releases are included in the ADMET Predictor user manual. If not, and if they're not on our website, then we're happy to provide those README files to get a bulleted list of all the changes from version to version.
Okay. All right. Well, thank you, David. Yeah, we do provide a very significant amount of documentation. I also want to say in closing that we are working on a set of tutorials that there will be, I believe, a total of 16 20-minute tutorials covering a number of areas in the software, including MedChem Studio. And we expect those to be out either on our website or on the YouTube, on a YouTube channel within the next month or so. So we'll certainly be reaching out to communicate with our clients when that becomes available. So I think we're pretty much at the top of the hour, so I think it would maybe a couple closing remarks if we can.
Yep. Just wanted to say thank you to Eric and David. We invite our audience to learn more about ADMET Predictor on our website at www.simulation-plus.com. We also look forward to seeing you all at the upcoming AAPS conference next month. And this concludes our webinar for today. The webinar has been recorded for playback and will be available on our website and YouTube channel. Thank you again.
All right. Thanks everyone for joining. Have a great rest of the day.